Which of the following pairs of molecules are enantiomers? Let's first define what enantiomers are. Enantiomers by definition are non-superimposable mirror images. Take a look at this molecule, for example. We can see that the molecule is flipped over in a y-axis but looks the same. However, if we were to assign R and S conformations to chiral centers, you can see that the left molecule is R and the right molecule is S. Therefore, they are enantiomers. To put it simply, enantiomers require all stereocenters to switch conformations. If you see in this example, all the OH constituents turn from wedged to dashed, and if you check with R and S assignments, you can see that they switch stereochem. Let's take a look at A now. If we were to assign R and S to each of these stereocenters, we can see that both the wedged bromines have R conformations, and the dashed bromines on the right both have S conformations. Because both of the stereocenters switch R and S, these are enantiomers. In B, only one of the stereocenters change. We can see that the dashed OH constituents stay the same in both, but only the bromine changes. These molecules are referred to as diastereomers, which means that not all of the stereocenters change conformations. C is a little bit tricky. If we assign R and S, we can see that the stereocenters switch conformations. However, these molecules are actually achiral because they are meso compounds. Meso compounds refer to compounds with chiral centers like we see here but have an internal plane of symmetry. If we flip the carbon bonds here, we can see this internal plane of symmetry. Even more, if we flip it over the y-axis to see the mirror image, we can see that these molecules are superimposable, meaning that they are identical and therefore not enantiomers. Finally, in D, we see that the stereochem of the chlorine substituent changes, but when we go to identify R as conformations, we can see that the molecule is actually achiral because it has two identical ethyl groups, meaning it is impossible to assign priorities. Therefore, these molecules do not have stereocenters and are not enantiomers. Thus, going back to the question, we can see that A is the only pair of molecules that are enantiomers.